Why are transverse waves visible? Why are transverse waves visible? The characteristic of transverse waves is that they vibrate in such a way that the waves move up and down in a medium and do not form a straight path. For example, we threw a stone into the water, and we can instantly see the movement of water in a specific pattern. The reason is water also have waves contained in them, so when a stone is thrown, particles in the water will vibrate up and down. The up and down movement is one of the main characteristics of the transverse wave. The wavelength of visible light has values that ranges between 400 to 700 nanometers. The rest of the waves in the electromagnetic spectrum will be not seen as the wavelengths differ. The transverse wave now will travel in any given medium as it has the properties in such a way that it does not follow a particular path. The properties of transverse waves are in such a way that they will propagate in a medium that is basically perpendicular to the direction of the wave. Whenever there is propagation, transverse is considered to have a two-dimension in them. So the light waves and radio waves are primary waves that follow the medium of propagation. The transverse waves exhibit a few characteristics of a wave, such as a wavelength, frequency, and amplitude. Having this information in mind, we need to move forward in determining the transverse waves and their direction as well. Mainly these waves are visible to the naked eye only observing the results of the wave propagation in such cases. How are transverse waves visible? Let us see using an example to understand how are transverse waves visible to the naked eye. When you strike a stick into any pond and move it in a circular motion, we can see a circular pattern. The circular pattern will tell us that the waves present in the pond are vibrated along with the tick that is in motion in the pond. So the particles that are present in the surroundings of the pond will instantly align themselves in the direction of the stick. When the stick moves, the particle present around will automatically move to make the vibrations circular, and hence we can witness the presence of the transverse waves in this particular process. Another good example is the resonance of the tuning fork. When a tuning fork is taken and stroked hard on the surface, the two ends of the fork will move up and down along with a diminishing sound as well. The above-mentioned examples are real-life examples that aid us in understanding the concept of the transverse waves in action. Why is visible light a transverse wave? Visible light is an electromagnetic wave made up of waves that carry energy as well. The waves, when traveling through a medium, they become an instant explanation to the transverse waves. The wavelength of light makes it to be observable in such cases. The particles present around the light waves will also start vibrating with the wave and move vertically to the medium that is right-angled to the direction. When we know that transverse waves are always in contrast to longitudinal waves, there will be a mix of both waves in a particular medium. For example, when earlier it was mentioned about the tuning fork, although the waves act in a straight direction, there is always an up and down motion of the waves. The light waves have electric fields and magnetic fields connected to them. So when a light wave is in propagation, the electric field and magnetic fields will align in such a way that we can possibly observe the visible light with our naked eyes. It is the main reason why light waves are visible to us rather than any other waves in general. Transverse waves will be visible when a particular wavelength of an electromagnetic spectrum becomes an observable quantity, and so is the light wave. The light wave is the one that has so many characteristics to it when we consider them in different scenarios. In transverse waves, the crests and troughs vibrate in such a way that the direction is always perpendicular to the medium of propagation. Frequently asked questions. Are radio waves transverse waves? All the electromagnetic waves are transverse waves, so is the radio waves. It is a known fact that radio waves come under the category of electromagnetic waves. Since electromagnetic waves are the best example of a transverse wave, radio waves are also transverse waves. sound waves are considered to be longitudinal, but this will be negated when EM waves are considered as a whole. Is a mechanical wave a transverse or longitudinal wave? Mechanical waves can both be transverse as well as longitudinal waves. Mechanical waves are the waves that require a material to propagate through. Basically, sound waves are termed mechanical waves as they require a material medium in order for their propagation. These mechanical waves can be transverse or longitudinal according to the medium chosen for their propagation. What do you mean by non-mechanical waves? Non-mechanical waves are the one that does not require any medium for their propagation or the transmission of energy. When energy travels in the form of a particle, then there will be a requirement of a medium for its propagation. So the medium-less wave propagation is regarded to the non-mechanical transmission like the electric field waves and the magnetic field waves. The mechanical wave requires a material medium for the propagation of the wave, but the non-mechanical waves do not require any medium. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.